afternoon or good noon, everyone. Can you hear me? Am I audible? Can you confirm? Well, first of all, thank you for joining. Can you see my slides as well? Is it visible to you? Perfect. That's good. Thank you for confirmation. As you already know, I guess that we are today here in one of the training session for the topic called responsible and ethical AI for the future action. And I'm presenting one of those topics in this big training program running from 5th of April to 24th of April. We're just in the midway. So I think it's a fifth training program lecture today and more to come, of course. Well, myself is Avinash Singh. I'm assistant professor here at University of Technology, Sydney, Australia, and work from the School of Computer Science. And I will be presenting you, might be a little bit different talk in the field of brain-computer interface, which is relatively new for some of them, and I try to put this training program in a way that it can inspire you, but at the same time also give you an idea how brain-computer interface and AI together can change the workforce, how you're going to work in a company and how you're going to deal with this all technology coming in. I mean, artificial intelligence already affecting a lot of things. For instance, large language model, or for example, ChatGPT, right? It's already helping a lot to do so many small things, generating content to fixing your grammar and helping you to create a content for a specific purpose, even doing some sort of a search, to generating new videos using generative AI and so on. It's affecting everywhere. Artificial intelligence already affecting our life day by day, every day. But after AI, what's the next is brain-computer interface, which is a significantly growing field. And of course, I'm going to talk about what this is all about if you have never heard that term before. But that's a very natural path. After AI, we're going to deal with brain-computer interface, or BCI. And definitely it's going to affect everything. And one of those important area where it's going to affect everything is the workforce. Like how you're going to work in a company is going to affected by BCI and AI. AI is already affecting it eventually. So let's dive into this topic and see what is all this BCI is all about. Whenever we take an action, right? Like I'm moving my hand now here, if you can see in my camera, this hand, or holding a coffee cup in my hand. Whenever I want to do a task, or a human body want to do a task, your signal go from, your brain signal, cortex, to all over different part of your body, muscles. I'm not going to talk about them in detail, but different part of the body and muscles until it reaches to your muscle to take an action. So in this case, my muscle, which is in my hand, taking an action of picking up this cup. And who is telling to pick up this cup? It's my brain, of course. So my brain signal is going to my muscle, giving the command to take an action to pick up the cup. Now, BCI, on the other hand, doesn't need all these pathways. You don't need BCI technology enable a way of communication where your brain signal can directly take an action. So I just think about picking up the cup, and maybe a robotic arm or something else which is available near to me take that cup, and that become an action. So essentially bypassing all these connection you may require generally when you take an action. And doing this is called BCI. So although brain computer interface have a computer in the middle, but computer have so much meaning. So according to one of the professor, a very popular one, John Woolpa, BCI is something, a way of communicating with a system that does not require peripheral nerves. It doesn't require your muscles. It just requires your brain signal. And with your brain signal to connect with the surrounding. So that's the BCI. Sounds very fancy. And in recent years, especially last 3, 4 years, BCI becoming very, very popular than ever before. Although it's there from long time. And you should ask why someone wanna do a BCI. That's also always a question, right? And there's so many reasons, but like any other technology, health is always a key element that inspire people to do something. So BCI is also came from the same place. Actually, there are about 50 million people, now this number is even bigger, suffer from some kind of impairment. Like you can see this lady or this person, they cannot move their hand or leg. I mean, they are paralyzed from below neck, or maybe even can't move their head too much. In that case, only solution can be seen as how about we just let them control things with their brain signal alone. And that's the inspiration of BCI come from. And that's why BCI, one of the first BCI came in existence. But if I dive further into it, I want to give you an idea. This is one of the first BCI in 1973 by Professor Vidal from UCLA, University of California, Los Angeles. He proposed, he developed one of the first BCI. But this BCI looked like this, a very huge number of experimental room, control room, and computer area. So it's 1973 we're talking about, which is quite a while ago, almost a half century from now. We don't have too much in the field of machine learning and AI that movement. And that means we have to do a lot of calculation, and so much calculation required as well as so much computation power required. So the whole BCI system is look like this to make it happen. And going from there, around 1999, one of the fully working BCI system came into existence by Professor Barmaumer, who is also known as one of the father of BCI system, where this professor made an implant to this person. This person had paralysis, he can't even communicate. And those brain signal go from his brain to pass to a system. Still a lot of number of devices are there, but this person is able to communicate first time. The system happened in Germany. So this person is able to type by his brain signal into this laptop. You can see here, very, very big, thick looking laptop here. And what he wrote a letter to Professor Barbaumer asking for a visit from him and his team. He was writing that he was honored to be depicted as a motivation artist without whom the letter would not have been written. I mean, this is all he typed in Germany using brain signal alone in 1990. So fast forward almost a half century since the first system, which is 1973, here I am. So this is the kind of work I do, where I generally develop BCI system that can do a range of things. Although my primary focus is not mental health or supporting people with disability, But whatever I do in my field of BCI, it help in so many different ways to pretty much all different kind of field. And how I like to call it is BCI is able to replace, restore, or enhance the capability of a user. When I say replace, essentially, replace is very similar to what we saw people with disability, essentially give them additional sensing, additional control. Restore is where we provide information in terms of how to enable their ability, and enhance, of course, further enhance the ability of a user to do stuff. So these are some of the work, and I'm going to talk about that, most of them in the following slides. So you will get to know how these BCI affecting you or maybe the future of workforce. So you might get a little bit idea. Now let's break it down, how actually BCI work and why we're talking about AI and brain signal and so on. So generally a BCI required your brain signal. How to acquire that, I'm going to talk in the following slide. How to get this brain signal to feed into your laptop or computer or computational device. Regardless, you need a brain signal. You have to get the brain signal before you can even do a brain-computer interface. Once you get the brain signal, this has to be pre-processed. So think of brain signal as a time series data. It's a continuous data, essentially looking like this, like you can see in the slide itself, is flowing signal. It's continuously coming to you. You have to pre-process to make sure, how we process the data in artificial intelligence to make sure there's no noise and so on, change the size, sampling rate. And once you pre-process, based on these two steps, you can extract features from this data. That feature can feed into a machine learning that essentially interpret these features and make a classification that can translate into an interface, right? So essentially what's happening, so these two steps, neural feature extraction and AI machine learning, are super important. Once you extract the feature, this is your machine learning or artificial intelligence that understand this signal. And once you understand the signal, you can essentially issue a command like a making robot move forward, backward, left, right, or making your computer cursor moving here and there and clicking some icon and making you give you a sound to speak something, things like that. Of course, there's a lots of limitation in BCI system, but these are the few way to interpret. Now you can see, like I mentioned, to make an BCI happen, of course, you need a brain signal. How to get the brain signal? I'm coming on that. And you need a machine learning. This presentation is not too much diving to machine learning and AI itself, but I want to give you a taste what it means to have an AI or machine learning. When we talk about getting brain signal for the BCI, there's a range of way you can do that. And these are just some of them. No need to go too much in detail. For example, you already know this kind of machine is called MRI or magnetic resonance imaging. Definitely not so suitable for BCI because bulky, heavy, expensive. Then there's another called MEG, which look like also very bulky, something on your head. You may also don't want a BCI system that requires such a carryover of big machine, right? And there are two new technology. Well, it's not new, but more feasible way of doing things. Something called FNIRS or FNIRS that required to brain that essentially capture the brain signal using infrared spectroscopy. And then one of the most popular one is called EEG, essentially record the brain electrical activity of the brain to get the signal what's happening. And that's the most popular at the right moment in the world of BCI. And interestingly, this EEG system, you see, they still looks very bulky, right? You can use fMRI, MEG, FNIRS, and EEG. But EEG came out as one of the most inexpensive, portable, and easily carry here and there kind of a system. And that enable lots of people who are interested in BCI collecting brain signal. And these are some of the example. Even more user-friendly and more portable version of EEG device that let you capture your brain signal. So you see, this essentially look like a headphone. You can put on your head like you use for listening song and talking with someone. And even on the top of that, they are not so expensive either. For example, this system on the number A is called Emotive. And this originated in Sydney. It's one of the most popular commercial device as far as I know, and can be buy in couple of hundred of dollars, US dollar. You can purchase such a headset. Same goes to this one. It's a NeuroSky headset, which is a very simple one sensor headset. Only little signal from the brain can be captured, but it's a very nice to get started with. And then we have this system, which is OpenBCI, that allow you to very flexibly arrange how you wanna make it look like, more like a do-it-yourself kind of approach. And that can also bought online easily with just a couple of hundred of dollars. All these ABC is like that. On the bottom, they are a little bit more expensive, but they are also very similar to the first range. For example, number 3 is called Muse headset that contain some sort of electrical signal to capture, some sort of a sensor to capture brain signal as well. So this is the device you can use. And of course, you can always use this fancy device, more expensive as well, if you are very keen in neuroscience. But for BCI people, might be EEG, and these kind of EEG headsets more than enough to do stuff. Now, on the algorithm side, literally a range of method can be used. And I'm showing you here in the slide, majorly method, which is inspired from deep learning. And this method, most popular one, is a discriminative model, and among them CNN, which is a convolution neural network, is quite popular in EEG signal analysis. People also use RNN, which is a recurrent neural network, help you because we talk about a signal which is a time series signal. So RNN is quite popular because it can learn from the past and the future information. And within RNN, we know there's a LSTM and GRU. Among generative model, GAN or generative adversarial network or autoencoder are also very popular, AE and GAN. People use them a lot, but these are other methods also getting popular over time where they are also performing very interesting performance in terms of learning from extracted feature of EEG. And of course, you can do a mix and match to create a hybrid model that can even perform very good for very special kind of BCI. So that's where the essentially AI comes in. And as we know, this deep learning model um, getting better and better to learn from the data. And same time, EEG device, the one I shared in the previous slide, are becoming more and more portable and easy to use. So essentially, they're coming more and more closer. In a way, the system I just showed you in the previous slide, a lab which full of bunch of different computer in 1973, you don't need that at all. This model can run on a small laptop, not necessarily very powerful. And not even though in my lab here in Australia, we run this kind of model in a simple Raspberry Pi. Raspberry Pi is a small pocket-sized computer that run on Linux. You can also run this model there. So you got EEG, you got Raspberry Pi based model, and you can put together to create your BCI. Now let's go look at some of the example of BCI. I'm talking different stuff, but how the BCI actually look like? What are the interesting approach you can use from that? Um, I'm going to give you two examples. So one first thing to highlight, the example contain flickering, and this could make a might discomfort some of you. So be careful. If you don't like it, just don't watch and look away from the screen. So one of the BCI signal you can extract from EEG is called P300. It's very popular. So think of a time series signal, which might look like this. You can in the figure here. Every time you see something infrequent, for instance, um, I show you a card of different animals in your card, and I ask you to keep eye on goat whenever goat will appear on those cards. So there's an animal like a buffalo, cow, and so on. Different card have different picture, but suddenly whenever a goat picture will appear, your brain suddenly will have some interesting feature around 300 millisecond, not second, 300 millisecond. And this signal, which appear at 300 millisecond after looking at the card, is called P300. This phenomena is so robust, so interesting that you can see this phenomena when you're looking at things, when you're listening something, as well as when you're touching something. So every time you're listening, uh, watching or touching something, and you will get something which is very infrequent, very unique, you get this P300 in your brain. P300, P stand for positive. So essentially it's a signal which look like a positive toward from the zero, and 300 means it's happened at 300 millisecond after you look at that stuff. So in this case, a goat picture. So just after you look at the goat picture, 300 millisecond. 300 millisecond essentially means 1/3 of the second, right? It's very fast. And it's possible to use just this tiny little signal to do a lot of things. And one of the most popular application of this P300 system, P300 based system, is P300 Speller. It's a system where user can put the EEG headset on his head and look at the all alphabet from A to Z, as well as 1, 2, 3, 4, 5, 6, 7, 8, 9. And he can just pay attention to which one he's interested in, and based on that interest, he's able to type a message. Very similar to what we saw in the previous slide around 1999 by Professor Burbaumer. So let's look at the example. How does it work? So user just going to focus on the screen, and you can see screen have flickering. Flickering is just to make user pay attention to specific line of the letter, vertically and horizontally. And every time user have interest, for example, letter O or letter V or letter X, P300 happen in his brain, and that P300 is classified by algorithm, by machine learning algorithm, and this classification translated into a command. In this case, it's a letter, and just show on the screen. So you can see on the top here, the letter is keep typing and it just keeps showing. So on the top is the task we asking person to do. So person has to type hands free. And in the bottom, person is actually using brain signal to typing that. Now, one thing you might notice, this approach is not so fast as how we can speak or type, right? And the reason is not algorithm are slow or brain signal are slow. This is a limitation of how quickly you can extract the feature specific to P300 and how robust you can do that. So in this case, it's times out, but almost user can write the whole sentence here, which is not a sentence, but just two words. And, and this speed of typing by user using all this algorithm is known as the information transfer rate, ITR. And this ITR, almost all the BCI system is trying to improve this ITR. And this ITR is getting better and better with the help of artificial intelligence. Let's look at another example. This example is called SSVP. Very, I mean, there's a fundamentally is very similar to P300, but the phenomena is very interesting. Every time you look at something flickering like this kind of icon near my cursor, your brain in your visual cortex also flicker or also generate the exact same frequency. For example, the frequency I'm seeing here is like maybe 5 hertz. 5 hertz means it is on and off 5 times in 1 second. In the brain signal, around this area of the brain is called occipital lobe or visual cortex. You can pick up exactly 5 hertz here as well. And then you can use that signal to classify using machine learning and send a command to your device or anything. Interestingly, this phenomena, again, very similar to P300, not just happen with eyes, also can happen with the ear, that means auditory, and also possible to happen with tactile, means touch. When it happens with auditory, we call it SSAEP. A stand for auditory. VEP means visual, so V stand for visually. Now let's look at the example of this specific kind of BCI. So in this screen, user looking at 5 different kind of SSVP, each with different frequency. And what I'm doing in this experiment, this is from the lab here. What I'm doing in this experiment, whenever user looking at a specific frequency, we extract the signal from his brain, signal data, classify using machine learning. And once we know which one is looking at, and you see each flickering is attached to one option, we send that classification to robot, and then robot take that action, and essentially, in this case, it's called eating assistant system, and feed the user using this system. Now, complexity with this kind of a BCI is, so you can see it's a big screen, there's a 5 option. And let's say if I ask you, do you want to use such a system again and again every day, where something is keep on and off very fast and slow, doesn't matter what speed, you will find it's a little bit annoying for your eyes. Your eyes may get tired. But at the same time, this is an excellent example of a BCI for a real world use case. For example, in this case, the student is behaving like he's a disabled person, can't move hand and limbs. But think about such a system for actually a person with disability would be very, very useful. And this is again based on very simple headset. You can see on his head, look like a headphone like you do every day. And it's also wireless. This is very similar to the system I showed you in the slide that just cost you a couple of $100 only if you want to buy one. So these are some interesting example of BCI. But how BCI can affect workforce? And that's what we're getting into in the following slide now. Now, well, BCI have definitely a range of applications like the one I showed you. You can let a person with disability type, you can feed the user, you can let them drive the wheelchair, and so on. BCI also use a lot in entertainment, where you can use the BCI to play a game. Although I don't have an example in my slide, but think about a BCI with virtual reality, where user can just use brain signal to control his character, move forward, backward, left and right, and so on. But interestingly, Recently, there's a lot of work coming out from different places. I'm not going to talk about those companies and places where workplace-based BCI is used, but more and more companies, more and more workplace are trying to use BCI for a variety of purpose. So these are some examples. What are these purpose we are using BCI? Now, again, artificial intelligence is inherent within this BCI application already. So this BCI couldn't possible if there's no artificial intelligence. And this even become better by progressing faster and very powerful artificial intelligence system. So let's look at some of the key area, I think, where BCI used in workplace. So BCI is already, BCI can be used for monitoring purpose. So think about you working in a computer and using your brain signal, your employer keep monitoring you. That's a one way. Second, your computer itself is monitoring you and giving you this information about your workload, fatigue, attention, telling you when to stop working or when to keep working, and so on. Something like how you have a Apple Watch or other kind of a watch you wear that can tell you how much you already run, how much you have to run more, and so on. BCI can be used for monitoring purpose, for self-monitoring as well as monitored by your boss in your company. That might not sound okay, right? Another example is BCI and workplace enhancement. Now, this one is interesting. Monitoring could be exploited, but enhancement is helpful for you. So BCI can enhance or even extend your ability to control a robot, in addition to what you already control yourself. So again, we talk about healthy people only. You can even, BCI can allow you multi-drone control as well, where one person is controlling drone from his brain signal, not just one drone, two drone, but more than two, or even four and five, and so on. BCI could use for training as well, obviously, but what a training which is specially personalized for you. It's not the same training for everyone, but very specific training for you, using your brain signal in a way that can continuously adapt to your requirement and your skill set. And very last one, I think, is a bit of exploitation using BCI to identify your skill set based on BCI. Now, this skill set, just using BCI to understand what you really very good to do that is an interesting application. But at the same time, although your BCI telling someone or your employer that you are very good to perform a calculation job, but the interest of you, what you are interested in, is writing an algorithm, for instance, but your BCI telling is you are a math guy, not algorithm. So it's a conflict, right? So it gives you a little bit less freedom what you can do. So, there's a both side of BCI and workplace. One definitely is improve your performance of your work, but at the same time provide an ability for your boss or your employer to exploit those information in a way that benefit the company. And so that's a kind of future we might be getting into. So let's look at the example of such application. So very first is a monitoring BCI. What that mean exactly? Think of a system where I use your brain signal and brain signal tell me you are feeling very tired. In other words, you're feeling fatigued or your work required a lot of uh, processing calculation. So you're feeling so much workload, like you cannot handle it anymore. When such a situation occurs, it's possible to use BCI signal to detect those conditions and provide that information to your computer again, back to computer. And that computer can make adjustment accordingly. To follow that idea, we did one experiment a while ago where we using workload to understand when is a mental workload is very high or very low, and when we should rely more on artificial intelligence and when we should rely on human. So this is the example. It's applied for air traffic controller. Air traffic controller job could be very, very complicated. And this is a cognitive load meter that show you uh, where you are. If you're in the red place, means your workload is very high, versus when you're on the yellow, means your workload is under control. Green means the workload is in the balance level. So if I go back to this video, 1 second. So try to follow the video, what it says. Try to perform the task. You know what I mean by workload. Oops. Look like I have no control. No worries. The video had 3 tasks. Task asks you to follow the dots. In this case, there was only 1 dot to follow. Now this task, follow the blue dot, change to red. There are 3 blue dots, change to red. Try to follow them. You will find that following those 3 dots is not so easy to do. And your brain is really trying very hard to remember where they are and try to follow them. Now, what if these 3 dots become 5 dots? It become incredibly difficult to follow this dot. And we are measuring brain signal of one user here. So this user already showing his mental workload is very, very high when the user is trying to follow the 5 dots. So that's an example that cognitive load can be monitored using EEG. Now, but the question you should ask me, what should I do by following cognitive load? There's a multiple thing you can do. In this example, what we are doing by following mental workload is telling the artificial intelligence that this person who's following the dot and he's highly cognitively loaded, his mental workload is very high, he or she cannot perform the job very well. So please take over this job and help this user. So you can use information from cognitive load to tell the system, in this case is a computer, to take care of the job you have to perform. And vice versa. When your mental workload is low, then you can keep doing it. When mental workload is high, you can let computer take over or give you a little bit AI assistance or artificial assistance in your job. Especially a job like air traffic controller doesn't quite use a lot of AI in their everyday work, but such a system can be helpful for that. So this is the self-help. It's helping you to make a better decision or having better performance in your job. But at the same time, same phenomena can apply where your boss, your employer also monitoring your cognitive load and or attention level or your fatigue level. Maybe at some moment of your day you are really not feeling interested in tasks, so your attention is very low and so on. And think about you getting paid in the end of the day or end of the month based on how much attention or workload you have every day. That might be not so good, right? So that's where the BCI become little bit not so happy feeling kind of BCI. But if it's a self-help, yes, it's very useful. I have another example. BCI can be used to enhance your performance in different way as well. For example, enhance with the help of a robot. In this case, I'm talking about something called physical human robot. A robot that required a little bit help from the user to make an action. And in this one, I also want to show you this particular work I'm going to show you in the following slide. Use not just machine learning method like convolution neural network, but also use reinforcement learning to let this system use the brain signal to do something about interaction between human and the robot. Let's see the example. So you can see the example, user wearing an EEG, which is not so fancy as the previous slide, like a eating assistant system. And he's holding a robot. This robot there's a handle where the two hand of the user is goes into, and he's using robot to play this game of reaching to the dots. Now what's happening here, his brain signal also feed into this robot, telling this robot to follow the command of the user. I call it adaptation, but in this case, it's the adaptation happening very fast. So in the end of the day, this robot become very compliant of the user, and that make user job become easy and user can perform better. So again, this is a very nice enhancement or extension of user's ability to control a robot using BCI. And this kind of application we might be seeing in coming years as well, where BCI and robot and the human, all three are working together. Another great example is also a kind of enhancement, but a little bit like exploitation as well. In this example, we're using a signal called motor imagery, which is a phenomenon in the BCI where if you just think about moving your left and right hand, you can control things just using brain signal. You not actually have to move your hand, but just have to think about moving left and right hand. And this is the one work from one of the colleague here in the lab who demonstrate how to control multiple drone using brain signal by single person. So this is the drone, and there's a similar drone of more than one. We call them UAV Storm, and you see the user is wearing this headset, which look like a, this is how the brain signal look like. So number of channel can make the signal become a lot more and less. So in this case, there are only 8 number of channels user is using. And now user is trying to calibrate the brain signal with the algorithm for motor imagery, machine learning, whatever you can call it, so that it can perform a very good performance in the task. Now I start using the one drone control. This drone can go left and right by user's thought alone. And now he's using 2 drones same time, very similarly. Now when he's using 2 drone also using partially a little intelligence or artificial intelligence to somehow manage each other as well, but at the same time they can be controlled by user, go left and right and so on. And there could be 3 drone as well. So you can see the job which might be required 1 person, or sorry, 3 person to do that, with the help of BCI is possible to control 3 drone by 1 person. So of course you are extending your ability to do this control, but at the same time you are exploiting as well. Now 3% job can be handled by 1 and so on. So that's another potential use, good and bad, both use of BCI. Another one which is around personalized, um, oops. Another example is personalized training. Now, this is an interesting BCI example. So the scenario I'm showing you, it tried to use the brain signal, and based on those brain signal uses, it tried to understand what information should show up in front of you. This is a kind of training platform using virtual reality that allow user to train themselves, but at the same time environment it become very complacent and adapted to the user need. Let's see this video if it makes sense. So this is a ship environment, like you can be a captain of the ship. move the ship around, like you can see, and outside the window of the ship, you can see there's a stone, there's other ships, and you have to avoid those ships. So it's essentially a navigation task in water using the ship. And when you navigate the ship, these information can populate in front of you using brain signal and some other signals as well from your body, and give you a better idea what to do and how to measure workload and so on. So essentially, you can make the environment become very um, complacent to the user's need. And such a training become very personalized training for the user to perform. This video essentially is the example of that, but it's not really using a lot of BCI element at this moment. But I hope it making sense what I'm trying to say. And now we are in the stage where, oops, now we are in the stage where we are even going beyond these fundamental BCI thanks to artificial intelligence and generative AI and large language model in last 2 years. That is possible to simply read the thoughts and just reconstruct them. Now, application of such a stuff could be a lot possibility, as well as rewrite sentence that become more persuasive, that become more easy to convey or easy to tell to someone. That kind of application coming from the BCI in the coming years. And this is not just only what happening right now, but what we're gonna see thanks to so many hardware to capture brain signal coming in the coming years, and so much powerful AI like a stable diffusion by Meta, by OpenAI, large language model, and so on by this company, we can even go beyond what I just showed you with a very brief example of using brain signal and artificial intelligence together. Now, you should ask this question here that how the world look like in coming years, what are the implications? Well, there's a study in 2020, a survey where this particular work did the survey and asked user about their feeling on different aspect of BCI technology, what they feel about safety. So you see, there's a large number of people in the orange have concern toward the safety. What about data? Who own the data? There's also a concern around that as well. Performance, neuroethics, there's also a quite, so all these blue showing the concern, and you can see first top 5 and 6 element like safety, specification, data security, privacy, performance, neuroethics. These all are significant concern among user. They are really wanna understand it more, but there's not too much information out there. And this is something I want to convey with this slide, that you are the next generation a researcher and a student. You might want to think about in this direction to use how we can utilize such kind of uh, powerful technology like a BCI and a AI together to make a responsible future where we don't harvest and utilize people's information in the wrong way, but in a very ethical way that benefit everyone. There are some work happening in that direction. If you want to have more interest, I encourage you to look at IEEE Brain Neuroethics Framework, where I'm also co-chairing a group developing neuroethics framework, that how BCI can be used for workplace. There's some other organization also doing something along the direction, like a Neurodata Without Borders or Neuroscience Information Framework that also can be give you a lot of information. If this is very first time you exposed to BCI, maybe this specific link is a short URL that ATRSU26 can give you some resource. It's from one of my BCI workshop, a GitHub page, which I run every year here in UTS. But this is just one of such resources. There are so much other resources you can find on BCI as well, especially BCI with EEG. With that, I want to say thank you for staying with me until this whole presentation. I hope it gives you some idea what possible with the BCI technology in coming years and how this fulfilling further with the help of uh, AI technology getting better and better. That means BCI is even getting faster, better. And BCI is the next frontier future after artificial intelligence. So you can always contact me. This is the LinkedIn address, but of course you can also look up me in UTS website, and you can always email me for more questions. And thank you for my students and colleagues whose content presented in this slide. And I'm open for questions. Thank you. So I can read one question in the chat by Sirirat. Yeah, Stephen Hawkins was a interesting case, and interestingly, he was also using his two finger to type, and BCI was not so powerful that moment. It's already quite cheaper, to be honest. But I'm talking about BCI with EEG. But BCI that required surgery and hospitalization, of course, is still expensive. But we are getting into the direction those technology also become quite cheap, quite inexpensive, that more and more people can access that. And this is a lot more than ever happening in this year, last year, and I believe following year even is more better word. Refer to all neuro tools could lead to say that there is no boundaries between our mind, every thought, and others if they can translate. Very true. Telepathy. If you can read the person's thought, there's significant concern on privacy. You can't even think, lie, or even just thinking about some ideas, which is not necessarily you want to do, but just you want to think about it, right? Those things become a bit violated. And that's the concern of neuroethics as well. We want to find a way that can also protect your privacy, but at the same time can progress the BCI technology. And that's what we're heading into. But possibility is really a lot. Can we present others or the tools to know our thought, just like the shield? I'm not sure what's the shield here reply, but current technology can't do that. But it's already possible to reconstruct the thoughts. For example, if I ask you to think about an apple or think about a scooter, and just in few seconds, that same, you're just thinking about it, and it's possible to use artificial intelligence to reconstruct the apple or scooter in front of you in the screen. So that's already happening now. And no doubt in that, in just in a couple of years, we're going to see a lot more. And I'm talking about this all not with the help of those heavy machines like MRI or MEG. I'm talking about this happen with the help of those inexpensive EEG device. So these tools shall be used or had currently used in real world in many use further than the health, right? Yes, true. Workplace. This is the main idea I'm trying to convey. Workplace is a major place where this technology can be used, and I think going to be used a lot to have a better performance in your task and so on. But definitely it can have a roots in everywhere: entertainment, personal use, health, and the workplace. But workplace is more concerning compared to other, because workplace controlled by employer. And if you're looking for a job, an employer asks you to sign a consent form to use your brain signal, the chances are very high that you will say yes, because workplace pay you and there's a money involved in that task. So chances of agree with what company want you to do is also very high, which is not the case with the health as well personal use or entertainment. Within 5 or 10 years, the humanoid robot shall have the neurology similar to It's complicated question to say 5 to 10 years where we heading with this technology, but chances are not too bad. Definitely, we have a more access of what's going on in the brain signal than ever before that can be utilized uh, to help this robot to learn and better. For example, the one I showed you where the human and robot interacting and human's brain signal is feeding into robot. So robot can learn about the human and they can work together smoothly. I hope this answer your question. And you can always email me if you like. Anyone have any other question? Okay, if no more question, then thank you everyone for listening. And like I said, you can always reach out to me via email or via LinkedIn or here and there. This is something maybe more new than ever before you have listened, but I hope it inspire you and think about certain technology which coming on your way specifically. Thank you again. Thank you for listening. Bye bye, everyone.